Okay, so our next one, we're going to be finding one more arc length. This one we get to play with some trig functions and a natural log. We're still asked to find the arc length. So y is going to be natural log of the cosine of x. Hopefully you recall from your Calc 1 days, if y is natural log of u, that y prime is u prime over u. So here y prime, u prime derivative of cosine is negative sine, so negative sine x over u would be cosine x. So our arc length, that didn't give you an interval. X is going to be on 0 to pi over 4. So we're looking from 0 to pi over 4, now that we have our bounds. Square root of 1 plus f prime of x squared times dx. So f prime of x, we know what that is. So s integral from 0 to pi over 4, square root of 1 plus negative times a negative kicks us back over to positive. So we have sine squared x over cosine squared x times dx. Here we can get a common denominator going. So our arc length integral from 0 to pi over 4 of the square root of cosine squared x plus sine squared x over cosine squared x. So this one we multiplied top and bottom by cosine squared x. And then cosine squared plus sine squared upstairs, common denominator downstairs, and hang on to your dx. Cosine squared plus sine squared, though, is just a plain 1. So s is integral 0 to pi over 4 of square root of 1 over cosine squared x times dx. So integral from 0 to pi over 4 of square root of 1 is just 1, square root of cosine squared cosine times dx. So integral from 0 to pi over 4 of, it turns out to be secant of x times dx. Now, another little recall from previous courses. Integral of secant u du is natural log of absolute value of secant u plus tangent u plus c. So our arc length, natural log of secant x plus tangent x, evaluated from 0 to pi over 4. So natural log of secant, remember, is 1 over cosine. Cosine of pi over 4 is root 2 over 2. And the reciprocal of root 2 over 2 is just root 2. If you'll recall for that. That's 1 divided by that. Divided by a fraction means multiplying by its reciprocal. We just get our root 2 out of it. So we have natural log of root 2. Tangent, remember, is sine over cosine, and since we're here at 45 degrees, sine and cosine are the same. So non-zero number divided by itself is always a nice pretty 1. And then we try the same thing with 0. Cosine of 0 is 1. 1 over 1 is just a 1. Tangent of 0, sine of 0 is 0. 0 over 1 is 0. So this would be natural log of root 2 plus 1 minus natural log of 1, but the natural log of 1 is 0. So we would get natural log of root 2 plus 1. So that would be our arc length for that. So then we finish it off with an area of a surface of revolution, surface area problem. Again, we're still just revolving things, so we can think of the cross-cut sections as being circles. So the surface area, 2 pi integral from a to b. I'm going to leave a little room here for just 1 second. We'll put the rest of the familiar stuff. Okay, so the idea is I want the surface area as we revolve. Well, if I'm making circles, the surface area is built out of circumferences. The circumference of a circle is pi times the diameter, or pi times 2 times the radius. So we drop an r of x in here, the radius. So we'll do a couple of quick derivations. Do the, let's see, and we want lateral surface area only. So, frustum of a right circular cone, take an ice cream cone, cut the bottom off of it. That's what they're talking about here. So, notice we have a couple of circles being formed here, a little radius and a big radius circle. So here we'll start at the origin. We'll call this radius little r. We'll call this radius big R. Of course, not being at 0, that would be, we'll call that the height. Okay, so first of all, notice that we've made a line here. Slope of our line, big R minus little r over h. H minus 0 will simplify down to just a nice pretty h. And our y-intercept is at 0r, so y is big R minus little r over h times x plus our y-intercept of r. So that means y prime then, this is a first power, so the derivative is just its coefficient, the constant big R little minus little r over h. Okay, one little relationship that we'll have going here. If I look just at this top triangle here, we have, I'll kind of zoom in over here. 0 to h is h. From big R to little r is big R minus r in height. And s is going to be our lateral distance here. And we're going to turn that into our surface area, lateral surface area. So we know that h squared plus big R minus little r, quantity squared, is worth s squared. right, so surface area, let's start following this pattern. 2 pi times the integral from, we're going from 0 to h, of our radius. The radius here is following this linear equation for this guy, so that is a radius of big R minus little r over h times x plus r times arc length, square root of 1 plus f prime squared, big R minus little r over h squared times dx. So here I can get a common denominator going again. So surface area, 2 pi, integral from 0 to h of, we'll just bring this first guy along as is, big R minus little r over h times x plus r, square root of, this is really an h squared at the bottom, don't forget about this guy. So 1 is the same as h squared over h squared. So h squared plus big R minus little r squared over the common denominator squared times dx. Little substitution, h squared plus big R minus little r squared, that is s squared. So s is 2 pi, integral from 0 to h, big R minus little r over h x plus r, square root of s squared over square root of h squared times dx. So a little cleanup on that then. Our surface area, 2 pi, integral from 0 to h of big R minus little r over hx plus little r times s over h times dx. So notice s and h, those are not variables in terms of r. We can just, or in terms of x, my apologies, in terms of x. So we can go ahead and grab those guys. 2 pi over 2 pi s over h, integral 0 to h of big R minus little r x over h plus r times dx. Okay, so we're ready to integrate. So our surface area, hang on to your 2 pi s over h. Antiderivative of a first power is a square. So big R minus little r over 2h plus rx, evaluated from 0 to h. So our surface area, 2 pi s over h. Plug in the h, I have big R minus little r times h squared over 2h. We'll get a little canceling there, plus RH. So our surface area, 2 pi s over h, big R minus little r, h over 2, plus RH. The x being 0 drops those two guys off, so minus 0. You just sort of drop it. Okay, notice h was a factor in both of these at the top, and then we have it once at the bottom. Goodbye to our friends, the h's. So surface area, 2 pi s times big R minus little r plus 2r all over 2. So here I'm getting a common denominator. Multiply this guy top and bottom by 2. And goodbye to our 2's. So S is pi times, I should make it clear that that's a lowercase s, my apologies, big R plus little r. Alright, so that should give you enough to play with for now. Alright, so in this one, so we're going at, this is section 7.4, 1 to 15, the odds, 37 and 56 should be plenty to play with. If you have questions, please get in touch with me. Otherwise, I will see you next time.